Hello everyone, this question is about vectors. With respect to the origin O, the points A, B, C, D, position, find the obtuse angle between OA and OB. So we use the MF19 formula for vectors, the only formula about vectors. We use the dot product. So if you rearrange here, so you divide both sides by the absolute value of A, absolute value of B, this is what we get. So cos theta equals A dot B divided by the absolute value of A, absolute value of B. So since this is between OA and OB, we use the OA 3 1 minus 1 2 and the OB, which is 1 2 minus 3. So this is factor A, factor B, magnitude of A, magnitude of B. To do this dot product, we use this formula here. So A1 times B1 and so on. So we do 3 times 1 minus 1 times 2, 2 times minus 3. This is the dot product formula. And for the magnitudes, actually we don't have the formula in MF19, and you gotta memorize it. It's the square root of the sum of square of each component. So the 3 squared, the minus 1 squared, the 2 squared, you add everything and put it in the square root. Same thing here, 1 2 minus 3 square plus square root. So if you use your calculator, you're gonna get minus 5 over 14, and to find the theta, we use inverse cos. We get the angle, 1 decimal place for angle in degrees. And the next part is the line L passes through the points A and B. Find the vector equation. So from the first part, we know the A and the B coordinates or position vectors. The line passing through means we can use the point A or B. So this point here can be OA or OB. Here I'm using OA. And for the direction, we can use AB or BA. So AB is B minus A. So AB is 1 minus 3, which is minus 2. And then 2 minus 1, which is 3. And minus 3 minus 2, which is minus 5. So that's how we get the vector AB. If you want to use the vector BA, that is fine, also correct. So the vector BA is the opposite. Now find the position vector of the point of intersection of the line L and the line passing through C and D. So the line L from the previous part is the line passing through A and B, and we have the vector equation already. Now for the line passing through C and D, we do the same thing as in the previous part. For the point vector, we can use C or D. Here I'm using C. And for the direction vector, we can use DC or CD. So here I'm using CD, which is D minus C. So 4 minus 1, we get 4. Minus 6 minus 2 minus 4. So minus 6 minus 2 is minus 4. And 11 minus 5 is 6. Okay, so we just subtract this vector minus this vector to get the vector CD. So we have the two vector equations. To find the intersection, we equate each component. So we do 3 minus 2 lambda on the left equals 1 plus 4 mu on the right. That's from the x component. And now for the y component, minus 1 plus 3 lambda on the left, and on the right, minus 2 minus 4 mu on the right. So using the x and y components, we can find the lambda and mu by substitution or elimination. So here we simply add, because we can cancel out here, and we get 3 plus minus 1 minus 2 plus 3. 1 minus 2 is minus 1, which means the lambda is minus 3. And after you find the lambda, you can find the mu using one of the equations. Here I'm using this equation, we replace the lambda with -3, so this is -3, and we can find the mu. So this is -10, so +2 both sides, divide by -4 both sides, we get mu. So remember, we have to check using the third component. So we use 2 minus 5 lambda on the left, and on the right 5 plus 6 mu. To check we have the right lambda and mu for the point of intersection, or whether they intersect or not. So we replace the lambda with what we have before, -3, and the mu with 2, and we make sure that the equation agrees with the lambda and mu values. So since we have something the same, this means we have the right values of lambda and mu at the point of intersection. So to find the intersection point from the original function, you can use the first factor equation or the second factor equation. Because it's an intersection, the point lies on both lines, the coordinates satisfy both equations, so we can just use any of them. So if you use the one with lambda, you plug in lambda, the one with mu, you plug in mu, but either way you get exactly the same result. So 3 times -2 is 6, so 3 plus 6 we get 9, and -1 minus 9 we get -10, and 2 plus 15 we get 17. Or you can use 1 plus 8, which is also 9, -2 minus 8, which is also -10, or 5 plus 12, which is also 17. Alright, I'll see you again next time.